Now it's time to see what is RIP and how RIP works. As you can see over here, I have prepared a list of points that are important for us to understand what RIP is. And next to it, you can see over here a graph that I made, and that's normally what I'm gonna use it in the upcoming labs, okay? Point number one is routing information protocol is RIP. That means the abbreviation of RIP is routing information protocol. Anytime you see somebody talking about routing information protocol, then he's talking about RIP. And then RIP is an IGP distance vector routing protocol. Here we have 2 points, IGP and distance vector routing protocol. IGP, I have already explained it before, but I will re-explain it now. IGP means Interior Gateway Protocol. What is Interior Gateway Protocol? Interior Gateway Protocol are routing protocols which works inside our autonomous system. That means that we have access to all the routers and we can configure them to have RIP or OSPF. And if we have Cisco environment, we can use EIGRP. Okay. That means that RIP will not work with the outside network. For example, internet. RIP cannot be connected to the internet as a routing protocol. Okay. Again, RIP works inside our autonomous system. Distance vector routing protocol. Distance vector is a dynamic routing protocol. We have 2 types. We have the distance vector and we have the link state routing protocol or dynamic routing protocol. Okay. RIP is one of the distance vector dynamic routing protocol. What does it mean, distance vector? Distance means how far is the destination. So RIP look to reach to a network, he will look how far it is from him or from the router to reach to that network. Okay. And vector means in which direction. So he looks to from which way I have to reach this network. For example, here, if we have to look at router 1. Router 1 will look how far for him router 3 is and in which direction he has to reach it. So how far router 1, you will see he needs 1 hop. We will see what hop is. It's a jump, okay? He needs 1, he needs 2, and he needs 3 to reach this network. 3 hops. And which direction? He doesn't have any other direction than this direction. Okay? So this is how RIP works. In another way, if I want to give you a better example, think you are driving a car and you're going to a city X, for example. Okay? And when you're driving on the highway, you can see city X is from this way. Okay? Straight. And you need 20 kilometers to reach the city. So if you put it like this, this is also how RIP works. Another way, if you have here, for example, another way to, let's say we have a router here, we have a router here, and we have a router here, and then this takes you to the network over here. Okay. Then router 1 has 2 ways to reach to this network. Okay, he has this way that we have just seen it, and he has this way. Okay, but then for him, he will take this option, number 1, and not number 2. Why? Because the distance here is smaller. You can see here, let me get another pen just to make it better. You can see here he needs 1 hop, 2 hops, and 3 hops to reach to this network. Okay, while here he needs 1 hop, 2, 3, and 4 to reach this network. Even though, imagine that this network over here has a higher speed than this network, so this one has a higher speed than this network or this route, still router 1 will go on option number 1 because it has less hop. Okay? So he doesn't see what is the bandwidth, he only see how many hops is far from him and from which direction. Alright, let me just clean it. Okay, so then again, this is alright, this is done and this is done. We go to point number 3. RIP is the oldest, with an L here, is the oldest dynamic route. Okay, and that's why you can see that RIP is very simple when you want to do a configuration on MyCritic routers, and it doesn't require a lot of knowledge because it's one of the oldest dynamic routes in the networking field. Okay. RIP works on UDP port 520. So if you want to enable RIP in your network, and you can sniff the traffic of RIP using some software for sniffing, you will see that port 520, UDP port 520 will be very active, and that's because RIP works on this port. Okay. Another point, the default administrative distance is 120. We have seen in the previous lectures what administrative distance is. So every routing protocol has an administrative distance. Okay. If the route is connected to the router, it has an administrative distance of 0. If it's a static route, it has an administrative distance of 1. If it's RIP, it is 120. The smaller the administrative distance, then the better the router will go to that route. Okay. By default, the administrative distance of RIP is 120. The upcoming point is RIP use hop count as a metric. I have just explained it now for you, that when he wants to reach to a network, he will look how far is this network to the router that want to reach to that network. Okay. And it uses what we call the hop count, means how many jump he has to go. Like here, he has to go 1, 2, 3 to reach this network. Okay. So each of those are called a hop. Okay. Now, there is a limitation in RIP that you can go up to 15 hop counts. So meaning, say that this network 3.3.3.3 was 15 hop away from router 1, then it can still be reachable. But if it's 16 hop, then RIP cannot reach it, because the maximum hop counts that RIP can go is 15 hop counts. And that's very important to remember. Okay, let me just take those out. So it has maximum hop counts of 15. Now, imagine that we now have enabled RIP on router 1. So here RIP is enabled. Here the process of RIP is enabled. We are going to see how we can enable RIP on those routers. So the dynamic route is working and the routers can learn route from each other. But just to say now we have already enabled RIP on those routers. What will happen is that each of those routers will send the routing table to the neighbor router. Like R1, he will send all his routing table to R2, and R2 also will send all his routing table to R1. Same here. Okay? And this way, every router will learn from the neighbor router the networks which are attached to it or connected to it. For example, if we look here and to the router number 1, how can he know the network, this network over here? Okay, he will know it from router 2. But router 2, how can he knows also about this network? He will know it from router 3. That means router 3 sends his entire routing table to router 2, which contains that router C says that I am connected to the network 3.3.3.0. Then router 2 look at his routing table and say, oh, this is an entry which I don't have it. I will add it in my routing table. And then he will send it also, he will send all his routing table to router 1, which includes also 3.3.3.0, which also router 1 doesn't know it. Then he will also add it as an entry inside his routing table. And this process is every 30 seconds. That means in every 30 seconds, each of the router is sending a routing update to the neighbor router of its entire routing table. Okay? So that's very important to remember, that every 30 seconds, they send the entire routing table to each other, the neighbor routers. Okay? Alright, so now also this one is is done. Now, if router 1 knows about the network 3.3.3.3 from router 2, okay, and if he doesn't hear in the routing update that it's sending every 30 seconds, he doesn't hear from router 2 anymore that it has in its routing table the entry of 3.3.3.0/24, okay, then if router 2 send the routing update to here without this entry, which was before, because possibly that this network goes off, okay, then in this case router 1 will wait 120 seconds until he put in his routing table that the network 3.3.3.0 is invalid. Okay, that means that this network is not anymore reachable, and then he will take it out from his routing table. Okay, so now we have passed through all those points. I will stop here and I will continue the remaining points that we have in the upcoming lectures.